right? So to conclude, like, what is a bottom-up approach? Again, summarizing. We were building the tree, so we have all these formulas. We have an idea how the tree should look like, how this algorithm should work. But where do you start coding in Python? Like, if you're a very new coder in Python, it's very hard to sort of start somewhere. It seems like overwhelming task. So I hope this video will help you to apply this bottom-up approach, where we said, well, we can't build this whole tree at once. So what we're going to do is we will just first learn how to split one node into two parts. We didn't even talk about data structure. We just started working with the whole data set. We said, well, if we have this whole data set, can we split it into two parts, right, in an optimal way based on some columns? So let's say starting with MPG. So can we put a threshold on MPG in such a way that we will split the cars in our data set by cylinders, right? So we have three classes of cylinders, 4, 6, and 8. Can we split them in the best possible way, just using MPG column? And that's what we tried to do, and we started with that. So we created a bunch of code here in the beginning, and we learned that to do that, we probably need to know first a few things, like, well, how can we count all the classes? How can we count, and we found that there's 3 classes, 4, 6, 8. How can we count instances in this whole data set of each class? And that's how we created these frequencies, and we used some lambda there. We did that, and then we're like, okay, we know how to do that. Can we calculate Gini? Yes, we can calculate Gini for frequencies, so we've learned that in the first cell. And then we said, okay, now knowing all of that, can we split MPG? Can we split this data set cylinders into two parts using the MPG column? And that's what our second cell was dedicated. We've learned some stuff, how to find split points and so on. It's not the best algorithm. There are better ways of doing it, but it was a simple algorithm, right? So we find all the unique MPG values, and then we found all the values between ascending order of MPG values. We call them in between, right? Between values. And those we evaluated as thresholds. So we used as thresholds values between these MPG values in our data set. And we tried all of them and picked the one which produces the lowest cost. Use lowest cost of these two, left and right hand side. And that gave us basically the tool set. So we've learned how to split the whole data set into two parts. And then we started wrapping this code scripts into functions in such a way we were hoping to create a portable function. So it's not the whole data set, that we should be able to just supply any node to our function and it's able to split it into two parts. And it could be any node down the tree. So that took us a lot of time, and then the trials and errors. Obviously, we made a few. Well, I made a bunch of mistakes, and spent like half hour debugging it, which was like very long and painful. But I mean, you can skip that part if you are not interested. But I think it gives you an idea how can we approach debugging, especially if you're a beginner programmer. And basically, what we've learned here is a bottom-up approach, right? So we were building up from a very low level, higher and higher, and we ended up writing this one giant function, a giant function of 4 lines of code, which creates the whole tree by the virtue of iteration. Iterative. You see, this function calls itself, but it calls itself on the left and right hand side. And then when you go inside that, it will again take this node, apply this function again, split it into left and right. And then it will apply itself on the left hand side and the right hand side. And when it's applying to the left, it's again doing left and right. So this is a recursive way of writing a function. It can be a little tricky if you didn't use recursion, if you're coming from a programming language which doesn't use recursions, but it's a very powerful technique. When working with data structures such as trees, I've shown quite a few code with loops. Loops are very powerful, But loops are very powerful too when you're working with sequential data structures. When you're working with something like a tree, the recursive functions are like recursion programming paradigm is easier to write. It's not necessarily the fastest. It's not the most performant. It's not always the best approach if you want fast, small code. But it can be. You have to have it in your like programming arsenal because it simplifies coding in many cases, specifically in visiting type of like you're visiting every node if you're doing something like that. Okay, so we've learned how to build a tree in this long set of videos.